First of all, I would like to introduce to a new system that we've just currently developed. So it's actually a markerless badminton motion analysis system. Now, this system, we are utilizing Kinect to actually benchmark and record the athlete's motion. Now, Kinect is actually a line of motion sensing input device developed by Microsoft, and it is as a controller used by Xbox and Xbox One. In a sense that it actually captures all the movement of a player, and then it will convert into data. So it is able to capture movement data and then record it down. So the actual point of recording is 20 joint points that can determine a human's movement. Now the problem we have in badminton is that we have to actually benchmark a player's performance to monitor how good it is compared to other players, or we would like to see whether they are consistent in their training, whether they improve or not. Traditional method of doing it is that we have to observe it with our own naked eyes, right? There is some problem with this method. First of all, there are some minute movement that we cannot capture with naked eye. And another thing is that we do not know that which area actually contribute the most significant difference between one movement and then the other movement that we would like to compare. And it is very, very tiring for a coach because we will need to run about 20 strokes for us to capture the problem. Now, traditionally, we will look at the footsteps. After they settle the footstep, we will look at the actual stroke and the actual movement. When we advance to the movement alone, let's say we would like to capture the hand movement. If we actually capture the hand movement, let's say it is movement number 20, there is a chance that the player might make mistake again on their footing. So it is not as a very whole, it is not a holistic way of looking at the athlete's movement. Then came another system, which is video capturing. What they would do is that they will capture the video of a play and then they will rewind and then replay again to try to look at the movement. This costs time as well because you will need to always replay and then play it back. As technology advances, we have a new system that actually uses marker to correctly captures all the joint movement of an athlete. This system we call a marker system. Now the best example is a Vicon system used by ISN, which is Institute Sukan Negara. This system actually puts some marker on your hands and then you are required to run it in a controlled environment. Now using a computer, they can actually sense your movement along with the video, then they can record down your movement. The downside is that we cannot use it on an actual badminton game. First of all, it is very cumbersome. If you stick something onto a body, then it will be very difficult for an athlete to move. Even the most basic swing, such as a smash, will actually cause the marker to drop out. Another problem is that during a formal match or official match, you cannot actually attach anything to the body of an athlete. So it is against the rules. Coming to this system, we are actually using Kinect. Kinect is actually a device that can capture an athlete's movement down to a certain range of meter. So the best thing about this system is that it can quantify data. Traditionally, we can only compare qualitatively whether they are raising their hand high enough, but we cannot say that how high it is. But with this system, we can actually quantify what is the difference between the first stroke and the second stroke, whether it is 1 centimeter higher or 1 centimeter lower. Another thing is that the athlete can actually perform the stroke in a more comfortable or natural way because they do not actually stick anything on their body and then they can just perform their movement. The whole thing about this system is that we can actually use it to benchmark an athlete's performance against another athlete. Let's say we would like to benchmark it against Lee Jung-wei. We will just have to take Lee Jung-wei's one of the movement, let's say a backhand stroke, and then we record our own athlete's stroke, then we can put it into the system. The system will actually run this algorithm, then come out with the data. They will come out with all the joints and then it will put down all the differences. What are the similarity of the athlete's movement and which joint is actually off the chart, which means that is the part that is not ideal movement. So we can actually do some benchmarking. Another usefulness for this system is that it can do consistency tests, meaning that I can perform my own test. Then after my training, I can come back and I have the same movement record again. we can actually see that whether I have some improvement or not based on this system against the first recorded system. Right now, we would like to introduce how the system actually runs. First of all, we would like to have a sample, which we call a reference movement. The reference movement is the one that we actually want to compare to. First of all, we will open the system. We can actually load a predefined reference. Next, we will take another shot on the movement that we want to compare. In this example, we show that this male player is the reference. Then his result will be indicated by the green line through the systems you will see on the screen. Next, we load out another player, which is a female player. Now her data will be a brown line. Then we can actually compare what are the difference, and we can actually spot where is the difference. And last of all, after the comparison, we can show a whole body percentage of the difference. Where are the difference of this athlete's movement? Further along the line, for future enhancement, we would like to put this system as virtual coaching. Nowadays, coaching is a very tiresome job. We will have to concentrate on one athlete. If it is 2 or 3 athletes, we wouldn't have time for that. Now, using this system, we can actually use it on the juniors athletes, whereby they can perform their own movement and strokes, and then use the system to benchmark or to see how consistent they are. Then we can develop a virtual coaching system. Next, this system is also very useful in medical field, especially in physiotherapy. As a psychological effect on a patient, if you are injured, the most significant thing that you would like to know is that do you have any improvement after a physiotherapy? For a naked eye, the doctor can only say, okay, you have some improvement, but how much do you actually improve? Now, using this system, we can actually quantify all the data. We can say that your previous movement is 80% to the ideal movement. Now you're progressing to 81 or 82 or even 95. So you're doing great. This can actually motivate a patient with a solid quality quantitative data.